You might hear this beep many times a day, scanning goods in a warehouse, checking out in a supermarket, or tapping your phone to open a web page. Behind each beep, there's a chip with a carefully designed storage structure divided into functional areas. What do these areas do? Let's start with EEPROM and explore the memory structure of RFID and NFC tags. In most RFID and NFC tags, the hard drive used to store data is a type of memory called EEPROM, which stands for Electrically Erasable Programmable Read-Only Memory. It has two key features. First, it is non-volatile, meaning data is preserved even without power. And second, it is rewritable, allowing data to be updated multiple times. This enables passive RFID tags to function without a battery, storing information securely for long periods when activated by a reader. In common UHF RFID tags, the standard divides the EPROM into four main memory banks. The first is reserved memory, which stores the access password and kill password, primarily for security control and tag-killing functions. The second is EPC memory, which stores the electronic product code, a key element for identifying items. The third is TID memory, where TID is stored to identify the tag chip itself. The fourth is user memory, reserved for application-specific data. EPC stands for electronic product code, and it is not used to assign a number to the tag itself, but rather to assign an ID to the item the tag is attached to. When a reader scans tags in a warehouse, the main value it reads is the EPC stored in EPC memory. Now let's look at TID memory. TID stands for Tag Identifier, and this part is usually written by the chip manufacturer during production. It generally includes information such as the manufacturer ID, chip type, and a unique serial number. In most designs, TID is read-only and cannot be modified by users. You can think of TID as the tag's birth certificate or chip ID card. The third area is user memory, which, as the name suggests, is storage space for user-specific data. This space can be used to store various business-related data, such as production dates and expiration dates, maintenance logs, service status, or status flags. You can think of user memory as a small notebook carried with the tag, used to record more detailed information related to the application scenario. After discussing UHF RFID, let's look at the more common NFC tags. NFC is a near-field communication technology based on RFID, commonly found in phone stickers, access cards, and transit cards. One important region in NFC tags is UID memory, which stores a unique identifier programmed by the manufacturer, usually read-only or protected. It functions similarly to TID in UHF tags, identifying the NFC chip itself. Another key area is user memory, or NDEF, which stores NDEF messages like URL links, text, vCard business cards, and Wi-Fi configurations. Finally, let's review. EEPROM is the storage technology for RFID and NFC tags, acting like the hard drive. Different standards and chips divide EEPROM into different regions. TID and UID are used to identify the physical chip, EPC is used to identify the item, and user memory stores business data and status. TID and UID are usually read-only. EPC is used for item-level management, and user memory is used for application data. Understanding these roles helps you have a clear memory structure when selecting tags and designing encoding schemes. The next time you hear that beep, you might think of the EEPROM inside the tag, silently reading and writing data, working quietly for your system. Thank you for watching. Don't forget to like, share, and subscribe for more insights on NFC technology.